Hello class, today we are going to talk about section 1.6, which is called algebraic relations. By the end of today's lesson, you will be able to display relations in multiple formats, classify independent and dependent variables, and interpret the graphs of relations. First, we need to review exactly what the coordinate plane is. This is one of the ways that we can put relations into a visual for ourselves. First, reviewing the x-axis, that is that horizontal axis that goes across the middle of the graph. Opposite of that, we have the y-axis, which is our vertical center axis. The origin is this central point on the graph. The coordinate pair for that is 0, 0. 0 for x and 0 for y. Coordinate pairs or ordered pairs are written in x, comma, y format. So the horizontal coordinate first and then the vertical coordinate. Couple things to remember on that. If the number is positive, if it is a positive x coordinate, you are moving to the right. If it is a negative x coordinate, you are moving to the left. For the y-axis, if it is positive, you are moving up. And if it is negative, you are moving down. So that's reviewing our coordinate plane. On to exactly what a relation is. That is a set of ordered pairs. They don't have to necessarily be in a specific order or create a specific image on the graph. It just has to be a set of ordered pairs. So the first way that we can display a relation is through a graph. So our first point is at 1, 2, so 1 to the right and up 2. Our second point is at 4, 5, so 4 to the right and up 5. Next point is at 5, negative 2, that's 5 to the right and down 2. Next point is at negative 1, 5, so 1 to the left and up 5. And our last point is at negative 2, which goes to the left 2 and then down 2. So this first representation of our graph is on, our first representation of the relationship is on the graph. Another way that we can talk about a relation is using the domain and the range. The domain is the set of x values and the range is the set of y values. The way that is most common to do that is by using what we call an xy table. So you would list all of your x values. The key thing about the x values here is they have to be in numerical order, starting with the smallest and going to the largest. So looking at our set of numbers, our smallest x is negative 2. So we have negative 2, negative 1, 1, 4, and 5. To finish up the table, you're going to match your y value up with its x value. So negative 2 gets matched with 2, negative 1 goes with 5, 1, 2, 4, 5, and 5, negative 2. Key thing here is that the x and y pairs are staying together. Your x's are in numerical order, your y's may or may not be. Another way that we can display a relationship is through what we call a mapping, or using a map, and it shows how each element in the domain, or the x's, gets paired with each element in the range, or the y's. So in order to make a map, you need a domain column and a range column. Similar to the table, our x values are going to be in numerical order. So negative 2, negative 1, 1, 4, and 5. Unlike the table, our range values are also going to be in order. So on this one, we're going to start with negative 2 because that is our smallest value in the range. If you notice, negative 2 is repeated twice, but I am only going to list it once. Same thing happens with 5. So if you have a number, whether it's in the domain or the range, that lists it more than once within your relation, you're only going to list it once in the map. To finish off the map, we're going to connect the xy pairs with arrows. So negative 2 is paired with negative 2. Negative 1 is paired with 5. 1 is paired with 2. 4 is also paired with 5, and 5 is also paired with -2. So each element in our domain is connected to its range value using an arrow. Go ahead, take a minute, and put this relation into a table and into a map. So your table should look like what is on the left, and your map should look like what is on the right. Again, remember with the map, that value of -3 is repeated twice, but we only have it listed once in the range. Next thing we're going to talk about is independent and dependent variables. Independent variables are what determines the output in the relationship. So this is actually the inputs, or if you are looking at an XY pair, it's the X values. It's what we're starting with. The dependent is the result of what is being put into the relation. We can call those the outputs or the Y values. So what your book is going to do is give you different scenarios, and you're going to have to pick out what is the cause and what is the effect, or what is the independent and what is the dependent variable. So for example, your hockey team is selling tickets to raise money for a trip. The more tickets you sell, the more money you will make. So in order to identify, we have our independent that we're looking for and our dependent. The independent value is this, in this case, is going to be the number of tickets sold. You decide how many tickets you sell. Based on the number of tickets you sell, that'll determine how much money you make. So the more tickets you sell, the more money you make. The less tickets you sell, the less money you make. Next example. The more time you spend studying for your math test, the better your grade will be. So again, we're looking for what's the cause and what's the effect. In this case, the time you spend studying is going to affect or change your grade on the test. Generally, more studying, higher grades. That's usually how it works out. Go ahead, see if you can identify the independent and dependent variable in this scenario. Independent is the time spent swimming. Dependent is the time spent reading. The more she swims, the less hours in a day she has to read. Last thing for this lesson is talking about analyzing a graph. So this is looking to break down and describe when a relationship is on a graph. What you want to do is look for specific trends or chunks in the graph and then relate it back to the scenario that they give you. So if you're looking at this graph down here, there's 3 specific sections that are easy to pick out. This first chunk, second chunk, and the third chunk. The scenario that they give us is describing how far you have ridden your bike compared to the number of miles that you have traveled. So a good description for section number 1 would be, as time increases, the distance increases. So you are moving from left to right on the graph, and your distance is increasing. So the amount of time you spent on your bike is increasing, and the distance is also increasing. That second section, your time is still increasing, but there's no change in distance. So you could say as time continues to increase, the distance remains the same. And our last chunk looks similar to the first chunk. So we're still having time increase, and our distance is also increasing. So you could say once again, as time increases, so does the distance. This is obviously a very basic way to write out these interpretations. The key thing here is to make sure that you are commenting on the independent variable first and then saying what happens to the dependent variable as a result. So just within that first one, I commented on the independent variable, that x of time, and then I said what happened to the y, or the dependent variable, as a result. If you have any questions about this or any other part of the lesson, please let me know when you get to class.